Hello everyone. This is the part 13. This is part 13 of full stack Python playlist. Okay, so this is not just a playlist. This is what? This is a training course. Training course for what? Python. Okay, Python full stack development. Okay, okay. Why this is a training course? Because we will also do projects after successfully okay, after successfully completed each module. When we complete module one, after that we will do project. Okay, that's why I'm saying this is a training course. I hope you will be clear about this playlist. Okay, so this is not just a video lecture. This is a training course. So in this course, we will learn theory in depth, coding in depth. Okay, we will do projects also from the scratch. Okay, so if you are the beginner, if you never created a project in Python or in any language, then this training course is beneficial for you because we are covering all the theories, all the theory we are covering. After that, we will cover all programs. Okay, we will cover all programs in depth. Okay, then we will create project as well. So that's why I'm saying, again, I'm saying this is what? This is not just a playlist. This is what? This is training course. All right, everyone. So decimal integer. In previous lecture, we already discussed about decimal integer, but in this lecture, I will give you a quick review. Okay. So what is integer? What is decimal integer? An integer value with base 10 is called decimal integer. Okay. An integer value with base 10 is called decimal integer. Okay, so what is the base of decimal integer? 10. So 0 to 9 we have symbols in decimal and we have base 10. In octal we have 0 to 7 symbol and base 8. In hexadecimal we have 0 to 9 and A to F and base 16, or we can say we have 0 to 9 and capital A to F, capital F, and base is 16, like that. Okay, so this is the basic idea. Let's understand. This integer is created using all the digits from 0 to 9. Alright, this integer is not prefixed with 0. Okay, so you cannot use prefix 0. Okay, for example, when you write a equals to 0, 1, 2, 3, it will give syntax error because this is not allowed in case of decimal integers. Would you like to try demo? So we can do demo as well. For example, let me search IDE Python IDLE. What is the full form of IDLE? So the full form of IDLE is Integrated Development Learning Environment. All right. So let's take a demo. For example, if we assign a value like 0, 1, 2, 3, then it will give syntax error. What it will give? Syntax error. So that's what I'm saying here. I'm saying this this integer is not prefixed with 0. So integer cannot be a prefix with 0. All right. As you can see here. Okay, as you can see here. Okay, for example, if I write simply 1, 2, 3 without 0, then when I print a, so it is allowed. It can print a value. All right, everyone. So this integer is prefixed with plus or minus. Okay, it cannot be the prefix with 0, but it can be the prefix with plus or minus. Okay, so let's take a demo. Let's take an example. For example, I want to write a equals to plus 1, 2, 3. Is it allowed or not? It is allowed. When I print a, okay, it will print a value. All right. For example, let's check with minus also. For example, I write minus 1, 2, 3. Minus as a prefix, and I'm writing 1, 2, 3. Or we can say I am assigning minus 1 2 3 in a variable or a object. When I print a, sorry, why it's giving error? Oh, let's try again, because we write print spelling wrong. That's why it is giving error. All right, let's do again. Okay. For example, let's assign minus value again 1 2 3. Okay, now I will print a, so it will print value successfully. All right. So what is the mean of it? So it's mean we can use prefix as a plus, prefix as a minus, no problem at all. All right. So default representation of integer value are in decimal format. So what is the default representation of integer value? Default representation of integer value are decimal format. Okay. For example, if I will use a equals to 0, 1 to 3, it is not allowed. Okay, it will give syntax error. All right. So for example, this is 125, 125. So it is decimal value, decimal value or octal value or hexadecimal value. This is what decimal value. How we get to know? With the help of this base. If the base is 10, it's mean this is decimal value. Okay, or we can say decimal integer. Okay, if the base is 8, it means octal value. All right, if base is 16, it's mean hexadecimal value. All right. So for example, we have this decimal value. Okay, so what is mean? What is the actually mean of this? So it's mean 10 to the power 0 multiply, we can multiply 5 with 10 to the power 0, and we can multiply 2 with 10 to the power 1, because 5 is because we have we can multiply like 1, we can multiply with 10 to the power 2. Okay, so 10 to the power 0 is nothing but 1, 10 to the power 1 nothing but 10, and 10 to the power 2 means 100. Okay, so when you multiply 5 with 10 to the power 0, it will become 5. When you multiply 2 with 10 to the power 1, it will become 20. When you divide 1 10 to the power, when you multiply 1 10 to the power 2, then it will become 100. And the when we plus all the value, the resultant would be 125. All right. Integer is allowed only one special character. So in whenever you are assigning any integer to a variable or object, you can use this special symbol. Only this special symbol, which is underscore, can be used in integer representation. For example, what I am trying to say here is, for example, if you are writing a equals to like 1 underscore 500. So underscore is what? Underscore is a special symbol. So this special symbol we can use. This is allowed in case of decimal integer. Okay, so it will not give any error. When I print a, so it will print normally. When I print a, so it will print normally 1500, 1500. Okay, so it's mean what? Underscore as a special character allow in decimal integer representation. Okay, so grouping digits are done using underscore. If you want to grouping the digit, you can use underscore. All right. Underscore cannot use as a prefix or suffix. We cannot use underscore as a prefix or suffix. Let's take an example. For example, I am assigning 500. Okay, and I am using underscore as a prefix. So will it give error? Yes, it will give error. Okay, so in prefix we cannot use underscore. All right, let's check with suffix. Can we use underscore in suffix? No, we cannot use underscore as a suffix or integer, suffix or prefix. But in middle, but in middle we can use like a equals to, like, okay, whatever. Let's open again. Ideally, and if I write like a equals to 500 underscore 500, sorry, 5 underscore 500, then it is allowed. In middle we can use underscore. When I print a, so it will print the value. All right. So this is another way of representation with underscore. Okay. So this is also an example. For example, amount equals to 500. So amount is, we can print like this. What is the type of amount? Integer. Because we are using, what we are using? We are using integer value. So the type of class is integer. Okay. When we create a and we assign value 10, so the type of a is integer. Integer is what? Integer is nothing but class. A is what? A is object. Object of which class? Object of integer class. What is 10 here? 10 is literal. Literal. Which type of literal? We can say integer type. Integer literal. Okay, what is this? This is operator. What type of operator? Assignment operator. Because it is used to assign the value in the object, or we can say variable. Alright. So here amount 2 equals to what? 1 underscore 500. It means 1500. So this is allowed. Okay, so the result print successfully. Okay, this is also allowed. Okay, what is not allowed? Suffix. We cannot use in suffix. We cannot use underscore in suffix. Okay, so it will give error, invalid, decimal, literal. Okay, we cannot also use in prefix. It will also give error. All right. Now we will discuss about octal. So if I talk about octal, so base of octal is 8. Why 8? Because we can use only 0 to 7 symbol. Octal give error if you will use symbol, like if you will use 8, then it will give error. If you will use 9, it will give error. We can use the combination of 0 to 7 symbols only. Okay, remember this. Let's understand theory. Octal integer. An integer value with base 8 is called octal integer. Octal integer is created using digits range from 0 to 7, as I told you earlier. Okay, this integer is prefix 0 or 0 capital O. Okay, so whenever you are assigning value, if you want to assign octal value to the variable, for example, a equals to, if you want to assign octal value, then you need to use, what you need to use? You need to use 0, you need to use 0 and small o, and then write octal value. What symbols you can use? 0 to 7 symbols you can use. For example, I am writing 2 and 3. So it is not 23. It is 2 is other symbol and 3 is another symbol. Okay, so this is how we can assign octal value. Or we can assign like this, 0 and capital O, then we can write 23. So this is also allowed. Let's try an example. For example, I want to assign octal value, then A equals to, we have to write 0 and O. Now I can assign 23, or we can say 2 3. When I print A, so it will give me the decimal value of 23. Okay, so is it like, how we can get to know whether it is correct or not? The octal 2 3 is equivalent to 19. Is it true or wrong or not? So we can use a website, octal to decimal conversion. So we can use online calculator to verify our answer. Okay, so we are writing 23 in octal. What is the decimal equivalent? Is 19. So 23 decimal equivalent is 19, as we already checked on, verified on website. This is what octal number 23, and this is what decimal number, which is 19. All right, let's continue again. All right, let me clean the board. Okay, so applications of octal integers. Applications of octal integer. assembly language and embedded applications. What are the applications? Applications is nothing but real life use. What is the application? Real life use of octal integers. Applications is nothing but real life implementation. Okay, so we can say in assembly language we can use octal numbers. In embedded applications we can use octal integers, representing an integer which does not allow digits 8 and 9, representing an integer which does not allow digits 0, 8 and 9. So we cannot use 8 and 9 in octal. Okay, we can only what digit in octal? If we talk about octal, so we can use only digits 0, 1, 2, 3, 4, 5, 6 till 7. Okay, from 0 to 7 we can use only, but 8 is not there and 9 is not there because base of octal number is 8. 8 means 0 to 7. Okay, so we cannot use 8 and we cannot use 9. Let's take an example. For example, if I want to assign octal value 8, 8, 8 or 9. Okay, so in order to write octal value, first I need to give prefix 0 and O. Alright, now I will write 8 and 9. So 8 and 9, will it allow or not? Yes, it will not allow. Why? Because it is out of range. Okay, invalid digit 8 in octal literal. So 8 is invalid because octal does not know about 8. Octal don't know about 9. Alright, so 8 and 9 is not allowed in the octal representation. Alright, because we don't have 9 symbol. We have symbol between from 0 to 7 only. But in decimal, we have symbols 0 to 9. So here 8 can be recognized and 9 also can recognize. Alright, for example, if we will assign 4 and 5, then it will not give any error. Okay, if we will check type, so this is an integer type. So when we type like 8 and 9, then it will give invalid digit 8 in octal literal. Alright, when we assign this number, because 8 is there, so it will also give error, invalid digit 8 octal literal. Alright, when we assign this value 3 and 5, so octal have 0 to 7 symbols, so this is allowed. This is allowed. So what is the value of 35? Let's check what's the value of 35 in octal. If we write 35 in octal, so what is the decimal equivalent? So decimal equivalent is 90. So here written is 20, sorry, 29. So decimal equivalent 29 of 35. Alright, and what is the decimal equivalent of 1 to 5? What is the decimal equivalent of 1 to 5? Let's check. So if I write 1 to 5 in octal, then what is the decimal equivalent? Is 85. Okay. So what is 1 to 5 octal number decimal representation is 85. Okay. So here is the like behind processing how we can convert decimal to octal. Okay, how we can convert decimal to octal? In order to convert decimal number into octal number, we have to divide the number from the destination base. What is the destination base? Is 8. And what is the number? Number is 88, 85. Okay, so we will divide 85 with destination number. What is the destination number? 8. So we will divide it 85. So it will इस तो हम इसे 8 से डिवाइड करेंगे तो ये इसमें 10 टाइम जाएगा. ओके, सो हियर वी राइट क्वोशिएंट एंड हियर वी विल राइट रिमाइंडर. हियर वी विल राइट क्वोशिएंट एंड हियर वी विल राइट रिमाइंडर. All right, and 8 when 8 cannot be divided by 1. Okay, so this one come here as a remainder and we will take value from bottom to top. So what is this? We will take 1 first, then 2, and this is 5. So this is what? 1 to 5, which is nothing but octal representation of 85. Octal representation of 85. If you want to convert octal value, okay, to the decimal value, so what you need to do? Write like this. 8 to the power 0, 8 to the power 0, multiply 8 by 5. So for example, we have 1 to 5. So write 8 to the power 0 and multiply it with 5. Then plus 8 to the power 1 multiply it by 2. Okay, then plus 8 to the power 2 multiply it by 1. So what is the sum of what is the 8 to the power 0? 8 to the power 0 is 1. 1 into 5. Okay, plus what is the 8 to the power 1 is 8 into 2. All right, what is the 8 to the power 2? 8 to the power 2 is 64. Okay, multiply by 1. So this will become 5 and this will become 64. Okay, is it correct or not? No, I am doing some mistake. This is what? This will become 16. Okay, this will become what? 16. 8 to the 8, 8. If we will multiply 8 by 2, then it will become 16. And here is 64 because 64 multiply by 1 gives 64. When I add this, then it will become what? It will become 85. All right. So this is how we can go decimal to octal and octal to decimal. Okay, so this is the actual way of calculation. How we can change the decimal to octal and octal to decimal. This is the conversion. Now we will see what is hexadecimal. Hexadecimal integers. An integer value with base 16, sorry, base 16 is called hexadecimal integer. Okay, if we have 16 base in hexadecimal, so it's mean we have symbols like 0 to 9, then A to F, or we can say 0 to 9 and capital A to capital F. Capital F. A is nothing but 10, B is nothing but 11, C is nothing but 12, and D is nothing but 13, E is nothing but 14, F is nothing but 15. So we have character from 0 to 15. Okay. 0 to 9 we have digits and A to F we have symbols, alphabets. Okay. This okay. This integer is created using 16 digit 0 to 9 A to F, or we can say capital A to F. This integer is prefixed with 0x or capital 0 or x. Let's take an example. For example, we want to assign hexadecimal value, then I will use 0x and I will write 13. Okay, when I print A, so it will give what it will give? Decimal value. Okay, if I check the type of A, so what would be the type? Integer type. Okay, so what is the type? Integer type, because this is what? Hexadecimal integer. What is this? Hexadecimal integer. All right, everyone. Larger integer value are represented in hexadecimal format. So if we have large value, then we can represent the large value in hexadecimal format. In computer science, if we have large value, like value is very big, then we use different number formats. Okay, we can use decimal, we can use octal, we can use hexadecimal, like that. Okay, what's the real life applications of hexadecimal integer? So what are the real life applications of hexadecimal integer? So we have like color values. We use hexadecimal value in colors. Okay, for example, if we want to write if we want to give white color, so we will use FFF. Okay, for the white color, this is what hexadecimal value of color. We use hexadecimal value in colors. Okay, or we can say we use in Unicode. Okay, because in Unicode we have more than 1 lakh values. More than 1 lakh values we have Unicode. Okay, in ASCII code, how many values we have? In ASCII we have 256, nothing but 0 to 255, which represent characters and special symbols. and if we have like other symbol which is not there in ASCII value, so for example chota a symbol which is not there in ASCII value, so the code of chote a is there in Unicode. So Unicode is what? Unicode is a superset. Unicode is what? Unicode is superset of what? ASCII value. ASCII value. So if the like if the symbols code is not there in ASCII, so we can find that character code in Unicode. Okay, because Unicode have more than 1 lakh characters code. Okay, more than 1 lakh values. All right. So let me clean. All right. So in Unicode, we can use hexadecimal integer in memory addressing because memory address is also large. Okay, so we can use hexadecimal integer in memory address. So remember this thing in color values, in Unicode values, and in memory addressing, we can use hexadecimal values. Okay, for example, prefix is 0x, it means this is the hexadecimal. Okay, so what is the hexadecimal of A is 10. What is the hexadecimal of B is 11. What is the hexadecimal of F is 50. Okay, like that. Okay, what's the hexadecimal of G? G is not there in hexadecimal because we have 0 to 9 symbols and A to F. A to F. So it cannot recognize G. It can recognize A to F symbols. Okay, other than A to F symbols, it cannot recognize. Alright, syntax error will come. It can recognize ABC, okay, because ABC is between A to F. The symbols out of this range A to F hexadecimal code will not represent, will not recognize. Okay, so FF will recognize by the hexadecimal integers. Okay, so this is the conversion. How we can convert hexadecimal value to the decimal value to the hexadecimal values. So this process is same. For example, if you want to convert this decimal value into the hexadecimal value, then you have to divide this particular value from the destination base. So what is the destination base? 16. So this is how you can divide, and here is your quotient and here is your remainder. Okay. So this is the simple conversion. Okay, what is 15 means in hexadecimal F, and this 15 means is also F in a hexadecimal. All right. So this is how you can convert from hexadecimal to decimal. What you need to do, you have to follow the same procedure like 16 to power 0 into A. Okay. For example, we have 1 and A. Then what do we have to do? 16 to the power 0 multiply by A. Okay, plus 16 to the power 1 multiply by 1. Okay, so 16 to the power 0 nothing but 1 and A nothing but 10. Okay, because we have 0 to 9 symbols and A to F. A is nothing but 10. B is nothing but 11. So same here, A is nothing but 10 plus 16. Okay, we will divide multiply 16 with 1, so it will become 16 and it will become what? It will become 10. So what would be the answer is 26. Okay, so this is how we can convert. Convert. So this is a number conversion. Okay, if we talk about binary. So what is the base of binary? Binary, binary base is 2. Bi means 2. Bi means 2. So we have only two symbol, either 0 or 1. Okay, so binary have 0, 1 only. Two symbols. An integer value with base 2 is called binary integer. Alright, binary binary integer is created using two digits, 0, either 0 and 1. Binary integer is prefixed with 0b or 0 capital B. Okay, for example, let's take an example. If you want to assign binary value, let's open again it. Okay, if you want to give binary value, then what do you need? You need 0b. Okay, then write 2. So it will give syntax error because 2 is not there in binary. Alright, if I write 0 b and 1 0 1 0, so 1 0 1 0 equivalent of, let's check in decimal. So it is the representation of 10. Let's check online. For example, we take binary here. If we write 1010 in binary, what would be the decimal equivalent? Is 10. Okay. If we write 1111, what would be the decimal equivalent? Is 15. So let's write 111 four times. For example, A equals to capital B is also represent binary and 4 times 1 1. Then what would be the value? What would be the decimal value? Is 50. All right. So what is the real life application of binary integers? What is the real life applications of binary integer? Okay, so applications is nothing but what's the implementation in real life of that particular number system or binary integer. Okay, so internal data representation, we can do the internal data representation. Machine language, binary language is what? Machine language. Machine understand which language? Binary language. Image processing, we can use binary integers in image processing. Audio or video processing, we can use it in audio and video processing as well. All right. So for example, we have 0b is the prefix to represent binary number. Okay, so if we have 1 and 0, so what is the equivalent? Decimal equivalent is 2. If we have 1010, what is the decimal equivalent? Is 10. Okay, so we have 10. All right, can we use 2? Because binary have only two symbol, even either 0 or 1 we can use. But how 2 is possible? 2 is not possible. So it is not allowed. It will give syntax error. All right. So thank you everyone for giving your valuable time. In the next lecture, we will continue learning more about the number systems. Okay. So thank you everyone for giving your valuable time. Okay. Always keep a smile on your face no matter what problems are going on, because with time every problems fade away. Okay. So as I'm saying, this is the training course. This is training course. So we will learn theory strongly, we will do program strongly, and we will also do project strongly. Okay, we will do programs, we will do theory, and we will do projects. Okay, after completing each module. If you don't know what are the modules we are going to learn in this lecture, then watch the first lecture of this playlist. In the first lecture, I explained you about each module, what we need to learn, what we will learn in this training course. Okay, so we will learn Django. Okay, we will learn Flask, and many things we will learn. I divided each module according to, like, according to UI module we will learn. We will use Python module we will learn. We will learn backend module, like that. All right. So please watch the first video as well if you want to give clarity about this training course. This is what training course course. Okay. So I'm going to charge you. I'm if you will take this course, training course, I will charge how much money? Nothing. I will not charge even a single money from you. If you will watch this video's lecture, I will not charge anything from you. Okay. So and this video lecture is really informative. Okay, so if you have technical knowledge, or if you are from Tech background or MCA or BCA background, then you can understand the potential of these lectures. Once you understand the potential of this lecture, then definitely you will learn from this lectures or learn from this playlist. Okay, so this playlist will not only help you in programming but also help you in interviews, in also help you in exams, in viva as well, because we will learn theory as well, we will learn projects, we will learn programs and everything. All right, so once again, thank you. Okay, again, smile and bye. Bye everyone for giving your valuable time, because time is money in today's time. Okay, so thanks everyone.